So our topic is electrical fields or electrical charge. First of all, there is an intrinsic properties which most of the fundamental elements have. For example, we know the fundamental elements or the elements or the thing which we have studied up to this point so far. These are not the fundamental. There are other subdivisions to them as well. But what we got up to this curriculum level is that most of the matter is composed of atoms or molecules, and because atoms are made up of proton plus neutrons into the nucleus, and there is electron or there are number of electrons which are going to orbit this nucleus, and that is the basic model which we know up to this point. Up to this point, I mean in your curriculum or in your syllabus. There is much more to this story, but this is what you will cover in your higher curriculum level, and not in this curriculum. And molecules are the combination of atoms. For example, two atoms combined can be considered as one molecule, or two or more types of molecules atoms combined in a group can be discussed as a molecule. So basically, group of atoms got into molecule if they are binding together by some forces. So what fundamental particles, which we call them right now, are electron. Electron is obviously a fundamental particle, but proton is made up of fundamental particle, but we are going to call it as a fundamental particle for now. Then electron, and then proton, and then neutron. These are the three particles, or you can say basic particle. The fundamental is not going to be more appropriate for proton and neutron because they are made up of other fundamental particles. So the basic particles which we have in an atom are electron, proton, and neutron. Proton and neutron are inside the nucleus, and electron is orbiting the nucleus. So these two particles, the electron and proton, they have an intrinsic property which is called charge. So you may be asking, or you may ask that what is intrinsic property? Intrinsic property means that whenever they got created, for example, when a proton came into being as a proton, and when an electron came into being as an electron, it may be at the start of the universe or when the universe was created, they had a property which is not changed till today. It was created as well with the creation of that particle, and it is same as of today. For example, whatever the mass of electron was at that time, it is same till today. So this can be considered as fundamental property or the intrinsic property. If fundamental property is that if it is not changes even slightly, so it is a fundamental property of that particle, and intrinsic means that it was created along with this particle. So this property is created along with this creation of this particle, so that is why we are going to call it an intrinsic property. For example, mass of electron is an intrinsic property, mass of proton is an intrinsic property of proton. Similarly, the charge of electron and charge of proton are also called the intrinsic property. Are you getting my point? And there are two types of charges. The one on electron is called negative, and the property which proton occupies is called positive. They are not, the positive and negative are just names. It doesn't mean that one is bad and one is good. So then we are just naming them as negative and positive. We can name it as A and B, we can name it as X and Y, we can name it as P and Q, anything we name it, but it was named as positive and negative. There are two types. They have similarities along with them, and they have differences with them, which are going to, this is the main thing which we are going to discuss. But there are two types. So the first property or the first thing you got to know about the charge is that it is an intrinsic property. You got it? The second thing is this: they are of two types. First one is positive, another one is negative, and proton occupies positive property and electron occupies negative property. So there are no other type other than these two types. And the third thing is that how they behave with each other. If they are like, for example, one is positive and other is positive as well, one is negative and other is negative as well, they will repel each other. If they are like charges, they repel each other. If they are dislike charges, for example, one is positive and other one is negative, they will attract each other. This is how they behave. You got it? The first thing is that it is an intrinsic property. It is there and it is, we cannot do anything about it. It is there and it is going to be there till the proton and electron will be there. So the second thing is that there are two types. The third thing is that the like will repel each other, and dislike will attract each other. This is how they are going to behave. The fourth thing is that they are quantized. By quantized, what we mean is that if we assign some value to the charge of one electron, and it is assigned by the scientist, his name was Coulomb, he assigned the one charge, one electron, as 1.6 multiplied by 10 raised to power minus 19 Coulomb. He assigned this as one charge of one electron. He could assign it as 1 Coulomb, but he did not. He came up with the calculation which was giving him as 1.6 multiplied by 10 raised to power minus 19 as the charge of one electron. That is why he called that this is the amount of charge for one electron which an electron holds. Because it is negative, so we will put a negative sign along with it. And the charge of one proton is exactly equal, which is also called 1e, and it is positive because of proton, and it is positive 1.6 multiplied by 10 raised to power minus 19 Coulomb. So quantization is that if there are two electrons or two protons, it will double. It will be 3.2 multiplied by 10 raised to power minus 19 Coulomb. There cannot be any value in between that. For example, there will be not a value of 2.4, there will be not a value of 1.9 into 10 to the power minus 19, obviously. So either one electron, either two electrons, either one proton, either two proton, and there can be number of proton and there can be number of electron, but there will be a gap between the values. They will not give us a continuous value. For example, for one electron it will be 1.6 into 10 to the power minus 19. For two electrons it will be 3.2 into 10 to the power minus 19, and then for three electrons it will be 4.8 multiplied by 10 to the power minus 19 Coulomb. There will be no other values in between these gaps. Are you getting it? So basically, quantization means that the charge will be equal to Ne, number of protons or electrons, or the charged particles, number of charged particles, and then the fundamental charge, which is 1.6 multiplied by 10 to the minus 19. So this is what quantization means. Or you can get it by simple example that there are x number of chairs in your room, in your classroom. So if there are 24, there can be 24. If they or 23, there will be 20. There will be not something like 23.5. Either they are 23 or either they are 24. So this is how this is this relate to quantization, and this is called quantization of charge. That charge is quantized, it increase with a certain value. So its formula is Q is equal to Ne, and N means that number of charge particles. This is very short review of things which are explained in first 7 pages of that chapter, but this is all what we need for solving the numericals. And then I am going to move to the Coulomb law. I will also explain it very short, because we had to do these for numericals, and that is why I am not explaining them in further detail. So the question arises, no going to Coulomb law. The question arises over here is this: when they are attracting or repelling each other. For example, if a proton is attracting an electron, which is the fundamental property, by what force they are attracting each other? The question is this, that what is the amount of force? So for finding the amount of force, the scientist whose name was Coulomb formed a law which is called Coulomb law. He formed a law using a torsion balance or the torsion apparatus, and he gave us this formula, that force which they will exert on each other will be equal to or will be proportional to the charges of their charges. For example, the one contains Q1, the other contains Q2. The whatever amount of charges they have, the force will be proportional to their product, and it will be inversely proportional to the distance between them. Our forces will be inversely proportional to 1 over r square. And then he combined these both just like gravitational law, and he got a value as constant k, which was, I will tell you its value shortly, but it got into this, that it was F is equal to k q1 q2 by r square. So this is called Coulomb's law, and value of k which he gave by calculating was k is equal to 8.99 times 10 raised to power 9, and its unit was Newton meter square per Coulomb square. This is what he gave. You got it? So this equation is called Coulomb law, and the parameters or the values which we are going to use is k, which is constant. Obviously it is written over here, and its units are also written over here, and the q1 is the first value of first charge, it will be in Coulomb. q2 is value of second charge, and r will be distance between them. And when we will put these values inside that formula, which is Coulomb law, we will get the force by which they are going to attract each other, or if they are like charges, for example there is a proton and there is another proton, so by what force they are going to repel each other. This is how we will calculate the amount of force caused by the charges. Okay, so I will close this topic at that point. In the next lecture we will start solving the numerical which will be given relevant to this topic, or if there will be other formulas we will discuss them, and then we will start solving the numericals or the home task.